Let's talk about the endocrine functions of bone, because this is where really everything is starting to go. A lot of the basic science literature and a lot of work. Turns out the bone, like the thyroid, like the testes, like the ovary, like the pituitary, spits out hormones. All a hormone is a little molecule, typically a protein of some sort, that communicates with systems or organs far away from where it was released. So it's just another way the body talks to itself all the time to get things right and to make sure we function properly. So osteocalcin is a very important molecule that the body makes, and it's only made by osteoblasts. What's an osteoblast? An osteoblast is the bone-forming cell. So osteoblasts, once a stem cell becomes an osteoblast, will just lay down new bone. So as it's doing that, it's also making osteocalcin. Well, it turns out osteocalcin isn't just important for bone health. It's also highly implicated in the regulation of glucose. So it can help control hyperglycemia if you have appropriate amounts of osteocalcin. And it's highly implicated in how the pancreas functions and produces insulin. And then it makes your bones and muscles more insulin sensitive to pull more glucose out of the bone. So osteocalcin is very important for energy metabolism, fat deposition, the ability to withstand hyperglycemia, things like that. But most importantly, it triggers the release of what's called brain-derived neurotrophic factor, BDNF, and this is a very important protein that helps your neurons, your brain cells, heal themselves, communicate better, form new connections, or become plastic, like we say, neuroplasticity, and also helps with cognition, memory, things like that over time. Osteocalcin is very important in how the mineral laydown in bone happens. So you get, think of like a bricklayer again. If you have somebody put brick down and they put the mortar in the wrong place, or it's too thin, or it's too thick, or they glop it all over, it's not evenly applied, your brick wall is not going to be strong. It's not going to be able to withstand time and force. Same thing in the human body. If you don't lay down that mineral deposition, that extracellular matrix just right, things don't work right. Osteocalcin is very important for this. Osteocalcin tells the bricklayer how to put the mortar down, how to connect it all, okay? So it helps with the proper mineralization of the bone. And then things like fibroblast growth factor number 23, very, very important for vitamin D3 and phosphate metabolism. These are one of the molecules that are being looked at strongly by the pharmaceutical industry right now. And then you've got sclerostin. Sclerostin is a molecule that is extremely important in bone health and growth. It is actually inhibitory of bone formation. So remember, you don't always want to be throwing down bone. Then we would just be a big mass of bone, right? You want it regulated. You want just enough bone. The bone needs to be just strong enough. You don't want too much of it. You don't want too much of it in the wrong place. Sclerostin plays into that. It inhibits what's called the WNT signaling pathway, which is very, very important for bone health. And it's crucial to the function of osteoblasts. And we're going to talk about some drugs that affect sclerostin and are being used in terms of bone health. But these are just some of the endocrine functions of bone. The primary one you probably need to remember or think about is osteocalcin.